Hey, it's Miss Sarika, and I'm going to go over the notes today about waves. So let's first start off and talk about what is a wave. So a wave is caused by any sort of vibration. Sometimes you'll hear it be described as a disturbance, and it's energy then from that vibration that travels out and goes in every direction. And when it goes in every direction, you'll hear the word propagation or propagates. So that's what a wave is. We've got this vibration or disturbance that now spreads out and goes in every direction. And that's the same for sound, for light, for earthquakes, for water waves, anything. You can see that when you throw like a pebble into a lake or a pond, you can see that the waves go in every direction. But it goes three-dimensionally as well. All right, the next question is, what is a mechanical wave? So there are two main types of waves. There are electromagnetic waves, and yes, that song is awesome, so cue the song right now. Maybe you can do that on your own time. And then there's mechanical waves, and mechanical waves are different because they need to have a medium. And a medium is an important idea because you'll hear it a lot when we talk about waves, but a medium is just a type of matter. So that could be, the medium could be rock for an earthquake. It could be water. It could be air. It could be anything. But as long as it's made of matter, it's considered a medium. So now how do we measure waves? So we talk about wavelength, frequency, and amplitude. So first one is wavelength. And what is it? Well, it's the distance between two similar points on a wave. That could be the top of both waves, which are crest and crest, or down at the bottom, which is called the trough. And so when we measure that point, that is our wavelength. And when it has high energy, which we should have learned from our lab, like over here, the wavelengths are really, really short. But over here, they're long. That's when there's lower energy. Okay, the next one is frequency. So frequency is how often a wave is going to pass in a certain amount of time. And so when there's high frequency, that's usually when there's high energy. And over here is when you have low frequency. Interesting connection. You'll notice with the wavelength and frequency that when there's a high frequency, there's a short wavelength. And when there's low frequency, it's a long wavelength. All right, now we get to amplitude. And amplitude is the height of a wave. And so it's how tall it goes from its center line and how low it goes from its center line. So you can see if it's high energy, it's going to have a high amplitude. And it'll be short and have low amplitude when it has low energy. So now we're going to look at, some types of waves. The first one is called longitudinal or compression. Kind of a tongue twister. I wanted to put both in there because the compression's a little easier to understand, but you'll hear longitudinal more frequently. So longitudinal, they hit each other, just like dominoes hitting each other. And it's compressional because you can kind of think that they're compressing and squishing together and then separating. So that's like when you take that slinky and you hold the edges and you kind of just push it like this. So you can imagine doing that. The next kind of wave is called transverse. Transverse. And transverse waves are the wiggly waves. And they are a little easier to see amplitude and wavelength. You can see them in longitudinal. It's just a little harder to kind of grasp. But in my picture here, you can see wavelength is from the top to the top or the crest to the crest. And amplitude is how tall it is. All right, so now we're going to look at density. And let's see if we can get all that. So the first question is, what is density? Because it may have been a while since we've talked about that in science classes. So density, there's a formula. It's mass divided by volume equals density. So that's great. Yay, a formula. But why is that important? So if we really break it down, mass divided by volume. So it's how much stuff, that's what mass is. It's the amount of matter, and volume is the amount of space it takes up. So the more space there is, and there's less stuff in there, then it's not very dense. But if we have this space and we cram it full of things, it's really dense. Think about a brick, regular brick, and a brick made of feathers or something. They both take up the same amount of space, but the brick that's brick is going to have more density because it has more stuff packed into that same amount of space. So when the density is high, the speed of a mechanical wave will also increase. It's different for electromagnetic waves, and we're not going to worry about that right now. But think about this. When the particles are really close together, like dominoes, if you stack them really close, it's easy for that energy to be transmitted and sent through them. But when they're further apart, it's a little harder for that message of energy to get sent. So for a mechanical wave, the speed will increase when the density is high. Now, when there's a change in density, it will change the speed and it will change the direction of a wave. And that's where that refraction gets in, which is over here at our wave behaviors. So the first wave behavior, though, is reflection. And that's kind of an easy one to remember because you could think of like a mirror and how the light bounces off of it. And that's what reflection is that a wave will bounce off of a new surface when it interacts with a new material. Sometimes that happens, sometimes it doesn't. It kind of depends on the wave and the type of wave it is and the energy that it has. But this is my picture over here. That green line is the wave reflecting. Over here is refraction. And refraction is different because when that wave enters a new substance, it kind of hits it and goes whoop and goes a different direction and usually at a different speed too. So this is our picture of a straw in a cup. That's a really easy example to think about. My other analogy for this, imagine you're running down the hall, which it shouldn't be, but you're running down the hall and all of a sudden there's a huge traffic jam. As soon as you hit all those people, you have to slow down and kind of make your way over that way. And once you get through the crowd, you can run again. That's just like what happens with waves, is it changes. Now, obviously that density is not quite right. Like if you heard before, remember I said that when it's more dense, a mechanical wave is going to travel faster when it's more densely packed. So that's not quite the best analogy for that concept, but the idea is the same, that it hits it, it changes what it's doing, and then it exits and does what it was doing before. So there you have it. If you have any questions, watch it again, pause it, and check your processing and see if you have any other things that you could add after listening. Maybe some examples kind of sparked up in your brain that could help you with this.